In this example, Claudio wants to invest $15,000 at 7.2% per annum for 3 years, compounded quarterly. He will receive quarterly payments of $1,400 for the life of the loan. So let's break down this question first. The first thing we see is the investment is for $1,500. We know that the interest rate is 7.2% per annum. Now it is being compounded quarterly, so obviously we'll have to work out what the quarterly interest rate is. We know this investment is for 3 years. 3 years at quarterly amounts will be a total of 12 times. He will receive quarterly payments, so notice it is compounded quarterly and quarterly payments. The two time periods are the same for $1,400. So, first part of our question says to us, write the recurrence relation that models the situation. Well, the first thing we know is V0, the amount we're starting off with, is $15,000. The next thing we need to do is work out what R is. R, now it's being invested, so is 1 plus little r on 100. What is little r? We are told 7.2% per annum, but we're adjusting quarterly, so we have to take the 7.2% and divide by 4. As you can see, I have done that on the calculator screen. 7.2 divided by 4 is 1.8. So we've now got R equals 1.8. So now to find the big R for our equation, that is 1 plus 1.8 over 100, which comes out to being 1.018. The other piece of information we've been given is the $1,400. That is the quarterly payment that is going to be made to Claudio. That is our value for D. So to write our recurrence relation, we have Vn plus 1 is equal to big R, 1.018, that is our quarterly interest rate, times Vn, minus D, our quarterly payment, which is 1,400. In the second part of the question, part B, we're asked, what is the value of Claudio's investment after 1.5 years? First way I'm going to do it is by first principles. The second way is by using the finance solver. The finance solver is not in the written notes. Claudio is starting off with $15,000. At the end of the first quarter, we go 15,000 times the interest rate minus the quarterly payment. That gives us a total of $13,870. For the second quarter, we take the 13,870, multiply by the value of big R, minus the 1,400, which gives us 12,709.7. Now it is likely that that is going to more decimal places that you're not seeing on screen because my calculator is set to show 6 figures. We then take that answer, which you can then see was 12719.66, not 0.7, times 1.018 minus 1400, and that gives us $11,548 and 60 something cents. That is at the end of the third quarter. End of the fourth quarter, repeat the same process. End of the fifth quarter, repeat the same process. End of the sixth quarter, repeat the same process. We've got there $7,907.48. The question asked to us, what is the value of Claudio's investment after 1.5 years? 1.5 years is 6 quarters, so there is our answer. If we were to use the finance solver, which you can do for almost all questions, you can see 1.5 years is 6 quarters, so n is equal to 6. I, the yearly interest rate, the per annum rate, is 7.2% per annum. Now, present value. Claudio has taken the 15,000 and put it into the bank. Claudio no longer has that money in his possession. It is in the bank, so it is minus 15,000. He is getting a payment each quarter of 1,400. He is getting the money, so it is positive 1,400. The compounding periods and payments per year are 4 because it is being done quarterly. You move on to future value and press enter, and you can see the answer, $7,915, then 0.74447. If you compare that to your calculator, you can see it is a comparable answer. It is not the same answer because of rounding. For part C, it says, will there be enough money in the investment for Claudio to receive his last payment? If you look at part B, you can see he started off with 15,000. At the end of one quarter, it had dropped. End of second quarter, it had dropped. End of third quarter, it had dropped, and so on down. So the question is asking us, will there be any money left there when it comes to the end of the 12th quarter? You could continue like I have done there by multiplying successive terms by 1.018, the interest rate, and then subtracting $1,400. Doing that, you can see it drops to $6,649.81, $5,369.51, $4,066.16, $2,739.35, $1,388.66, and lastly, at the end of life, it has $13.65.55 left. So we can see from there, what should his final payment be? Well, his final payment should have an additional $13.66 added to it. So it would become $1,400 plus the residual amount. So we would have 1,400, the normal amount that comes out, plus the $13.66. Notice going to 2 decimal places, which would give me a total of 1413.66. If we were going to do this using the finance solver, We know that N is 12, that is 12 quarters in 3 years. We know the interest rate is 7.2% per annum. We know the $15,000 was put into the bank. Claudia doesn't have it, so it's minus 15,000. We know the payments coming out quarterly was 1,400. Claudio has that, so it's positive 1,400. And we know the payments and compounded periods per year were 4. Going on to future value, using enter, you can see 13.655 as we got doing it by hand. This is the residual amount that is left in the bank, so that amount has to be added to the final payment of $1,400, giving you the $1,413.66.